Question 5. Longest palindromic substrings. Sounds very familiar with the popular questions. Longest common substrings. And there's another question called longest common subsequence. So if you want to solve this problem using dynamic programming, then you might refer to the solution for these two problems. But I would say the solution of these questions using DP will be slightly more complicated than these two problems, because we need to deal with the more details about how to determine if a substring is a palindrome. And our intuition tells us that using DP will end up with a solution that takes O n the power of 2, so n squared. It's kind of gives us a hint that if we can come up with a solution that's more simple, something very similar to maybe sliding windows, carved way, which can also lead to a time complexity of n power of 2, then that would be a better solution that you can come up during the interview. So this question is actually pretty popular during the interviews. You can see that Amazon and Microsoft like to test it, and I don't think they expect you to come up with a DP solutions in these problems. So this is the method that I'm going to implement. LeetCode called it expands from the middle. Right. So it makes use of the characteristic of a palindromes. So let's use examples ABA. So let's expand it. So this palindrome itself, we can see that if we can locate where is its middles, which is this B, and expand from the left and expand to the right, it only takes O(n) to kind of detect if it is a palindromes, right? So what does it imply? If we have a very long word such as blah blah blah, and then we have AA, BAA, and blah blah blah, and we want to find the longest palindromes, we just to do the same things like here, like 11s on every single characters, right? Every single characters. We expand from every single characters to the left, to the right, and it will sum up into a time complexity of O the power of n times n, which is also n power of 2. So the time complexity will be same as what we done in DP. So it's obvious that this solution is much more easier to implement, maybe in 20 minutes during the interview. So let's start coding. Yeah, so let's use a for loop to iterate through the strings I is more than s dot length I plus plus. Yeah, we also want to have a max length equal to 0 to record our current longest palindromes. And since the result wants us to output a string, so we want to also record the result, the string's left index, which is equal to 0, and the string right index, which is equal to 0. So in this case, we actually assume that the length of the string is at least size of 1. So we can, of course, we can clear this base case by saying that if s dot length is more than equal to 1, then we will return s itself, right? So yeah, so in this case, we can ensure that s dot length is at least larger than 1. Yeah, so let's start coding. There's two cases of palindromes. First palindrome will be something like AABB. So we can see that at the middle, there's nothing at the middle. Or we can see the middle is actually A and B. So if you want to expand from the left and expand from the right, then we need to expand from this A and this B. For another type of palindromes, is something like AACBB. So we want to expand from left and right, then we have to expand from this A and this B, or we expand from C and C. So you set both the pointers left and pointer right at C. Yeah, so let's do the expansions. Expand from middles, and we say expand another expanding from middle and middle plus 1. Yeah, so this is to counter for case AABB or AACBB. This for the cases such as AABB. Yeah. So let's write the inbuilt functions to expand from the middle. I believe we no longer need this, so just remove constant expand from middle equal to expand from middle equal to yeah, so we take in strings, we also take in a left pointers and a right pointer, right? So we say that while true, and check if the left -1 with less -1 equal to s right +1. If not, we will return an array that indicating the left and right pointers of the longest palindromes that we can find from this middle point. So if left -1 is smaller than 0, or right +1 is larger than s dot length -1, then it means there's no way for us to get a better palindromes because it's running out of the boundary. Otherwise, we want to check the values, right? So let's copy this. Yeah, if any of this happen, then we'll try to break the loop by simply returns the left and the right. Otherwise, we will update the counters by reducing the left pointers and incrementing the right pointer. Yeah, so it's actually guaranteed that this while loop will break. I know there will be a better way of solving these questions, but in the interview, this is what we're going to do. Very short and precise, short but not precise. So for the first one, we want to expand. We will say constant array1 is equal to expand from middle s, I, and I. For case 2, slightly complicated. So we have array2 is equal to I, and then if it's not the last characters, such that we have a next character to be compared with, which means I +1, then we will proceed. If this is smaller than this, and we also want to make sure that the first 2 pointers is a valid pointers. So which means we want to make sure that si is equal to si +1. Then we will update the array to expand from middle si and I +1. Or otherwise, we will just treat it as single characters. So like any characters with a length of 1. With this, we have gotten the left pointers and the right pointers of the longest palindromes that we can get from this expand from the middle and expand from the middle and the middle of the next. So we want to update the max length. So we will say if array, let's calculate the length first. So length 1 is equal to array 1 minus array 1 0 plus 1. The same go with length 2. It's simply saying that the right pointers minus the left pointers plus 1s. Right, you can do your simple calculations. This will be the length of the palindromes that you find during the previous steps. So we will say if length 1 is larger than the max length, then we update the max length to length 1, and also update the string left to array 1 and string right to array 1 what am I doing? 1 0. So left and right. And if the length 2 is larger than the max length, then we also update the max length to length 2 and do the same things again. Ta-da! Yeah, so here we are. Let's output the final result. So what will be the result? The result will be simply return s.slice. Slice from what? String left, string right. Remember, do +1 because when you want to slice an array or slice strings, it will take about left and right, and this is actually a square bracket instead of it's a circular bracket, right? Round bracket instead of a square bracket, which means the number you put in here is not included, right? It's precluded. So let's try. So let's use a more complicated test case. We also want to define our base case. So let's try with A. Let's try with A and B. Let's try with A, B, A, and try with the base case of empty, and also try with base case of A, B, B. Let's do something like E and this. So okay, must leaf has a size of 1, so PO. Seems pretty okay. So let's submit. We are done with these solutions. So let's analyze the time complexity again. So we are iterating through the whole strings, which takes O n to iterate. Right. So or it takes, we can say we want to iterate n characters, and then for each characters, we expand to the left and right, which takes at most on. So time complexity will be and the power of 2. Space complexity, are we using any additional strings, array, data structure to store our temporary result? No, we are not. We are simply using a left index, a right index, and the maximum length, right? So the space complexity is constant. Okay, so a bit sleepy. Yeah, that's all for our solutions and today's sessions. For the source code, you can refer to the GitHub link provided below, and for other solutions that written in JavaScript or Python, you can refer to the